Okay, we're going to talk about Chapter 3, Sections 3.3 and 3.5. They kind of go hand in hand, so I put those sections together. And we're going to focus on the median. We focused on the mean for the past couple sections. Now we're going to focus on the median. So remember, the median is the midpoint of the distribution. To find the median, we're going to arrange all the observations, generally small to large. If it's odd, the median is the center number. If it's even, the median is the center of the two observations. So we're going to go back to Michael Jordan and Kobe Bryant's data, which we remember we have in list 1 and list 2 in our calculator. But let's talk about doing it by hand. So for Michael Jordan, we have 15 observations, an odd number. And for Kobe Bryant, we have 16, an even number. So step 1, we take those observations, put them in order. And notice when there's an odd number, 15 observations, we can count there's 15. So the 1, 2, 3, 4, 5, 6, 7, 8, I'm going to circle it. The 8th one would have 7 on the left, 7 on the right. So the median would be 2431, 2,431. When we have an even number like 16, we're going to go count 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's between these two values. So we would add them up, divide by 2, take the average of the two, and get a median of 1,954. Remember, we can check all this in the calculator. There are two ways. You're probably leaning towards one, so I'm going to do stat, calculate one variable statistics for list 1 for Michael Jordan. X bar is the mean. We're looking for median 2431. For Kobe Bryant, who's in list 2, we do stat, calculate one variable statistics, list 2. Scroll down, MED for median, 1954. Okay? And again, we'll start from the home screen, and we had two different methods for finding it. I just showed you this one here, method 1, but you can also do method 2. And then we're going to talk about something else. When we do mean, we do standard deviation. When we do median, we do something called a 5-number summary. So I'm going to kind of work it out and talk about what those 5 numbers are and why. So the 5-number summary is basically 5 numbers consisting of the median, number in the middle, the minimum, first number, lowest, and the maximum, the highest number. That's 3 of the 5. Then we have these other ones called Q1, first quartile, Q3, third quartiles. The first quarter of the data, the third quarter of the data, basically cutting our data up into sections we can talk about. Q1 is the median of the lower half. Q3 is the median of the upper half. Now you're wondering why it goes from Q1 to Q3. Where's Q2? Well, the median is Q2. That would be half the data. So we're basically cutting it up into quarters. So we're going to go ahead and do these two examples and label those. Plus we'll talk about a couple other things like range and interquartile range. So we put the data in order, and we'll do Michael Jordan first. The median we found is 2,431, and we circled that one because there's an odd number of observations. The minimum, 408. The maximum, 3,041. Now, because we circled the middle one, we're not going to use that observation. So when I find Q1, we're going to do 1, 2, 3, 4, 5, 6, 7. There are 7 numbers. So if there are 7 numbers, the 4th one would be the median. That is Q1, 1,640. Again, we do not use the median that's circled. We use 1, 2, 3, 4, 5, 6, 7. The 4th one would be the median, Q3, 2,633. And these would be your 5 numbers. We'll check them in the calculator in a little bit. Now, something else we can look at is the range and the interquartile range. The range is when you take the highest minus the lowest. So in this case, the maximum is 3,041 minus the lowest is 408, giving us a range of 2,633. Now, some people would stop there and say that's enough, but remember, this is basketball. Michael Jordan, what if he had a really, really amazing season and a really, really, really bad season or was injured? Then his range could be really high because of these extremes, and maybe someone would say he's inconsistent. So another way to look at that would be the interquartile range, the inside range. So instead of doing high minus low, we'll take Q3 minus Q1, which will get rid of these extremes. or possible extremes. So Q3 would be 2,633 minus Q1, which is 1,640, to give us an interquartile range of 993. Okay, Kobe Bryant is even at 16 seasons, so let's see there. We found the median, which is between two numbers this time. The minimum is 539. The max is 2,832. But when we find Q1, we didn't circle the median. It's between two numbers. So yes, we're going to use the 1938 down, and yes, we're going to use the 1970 up. So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers in the lower. 1, 2, 3, 4, 5, 6, 7, 8 numbers in the upper. So with these 8 numbers, the median would be between the 4th and the 5th. So we'd add 1485 plus 1557 divided by 2. The average would be Q1, which is 1521. 1, 2, 3, 4 between the 4th and the 5th. The median would be 2201 plus 2323 divided by 2. The average, Q3, would be 2262. So those would be your 5 numbers. The range, again, high minus low. 2,832 minus 539, which is 2,293. And the interquartile range, which is Q3 2262 minus Q1, which is 1521, gives us an interquartile range of 741. But we have to stop and say, why are we doing all these numbers? Well, let's say they're both amazing basketball players, but you can only afford one. And we're going to compare our minimums, Q1, medians, Q3, and maxes, and our range and interquartile ranges to see if I had to pick one, which would I pick and why. But let's first check to see if our numbers are correct. So we go to the calculator, stat, calculate, one variable statistics, list 1 is where Michael Jordan is, enter, scroll down, and we can check that 5-number summary is correct. Clear. Stat, calculate, one variable statistics, list 2 for Kobe Bryant. Scroll down, and those 5 numbers are correct. Now again, we're going to compare everything and see who's the better player, but we may want to do a little further. People don't like staring at numbers, they like to stare at pictures. So how can I have a picture of what's going on? So that picture is called a box plot. So I'm going to show you how to do that on the calculator. And what I'm going to do in particular this time is do a side-by-side box plot. So the first one would be Michael Jordan. So we're going to hit second y equals, go into plot 1, turn it on. Now the first one is a scatter plot, the second one is a scatter plot with the dots connected, third one's a histogram. Now the fourth and fifth are box plots. The difference is the fourth one has these little dots, this one shows outliers. That is our modified box plot. The other one does not. So I want the modified box plot in this case. I'm going to choose list 1 for Michael Jordan. Leave frequency alone, leave the box alone. This is, you can choose your outliers to be boxes, pluses, or dots. I'm going to go up, up, up. So I don't have any other options. Zoom 9. That is Michael Jordan's box plot. Now, what is a box plot? If I hit trace, you'll notice there's your median, Q3, max, Q1, minimum, and what we're doing is, that's his minimum, 408, that's his maximum, 3041, but that's probably not what I'll get out of him if he's on my team. Most of his, 50% of his data, because remember each one's a quarter, 25%, 50% of his data is here in the box. So mostly I'll probably get a player that's going to score between 1640 and 2633. And to connect everything, if we think about shape, would this be symmetric, skewed left, or skewed right? Well, you notice the majority, the 50% here, that's kind of like the hump. There's a drag. This can be considered skewed to the left. So they're all connected. But I want to see Michael Jordan and Kobe Bryant all in the same picture. So I want to see 2. So I go to second y equals, leave plot 1 alone, go to plot 2, because I want to see 2 pictures, turn plot 2 on, choose the modified box plot again, but have this be Kobe Bryant, list 2, move up, hit zoom 9, and you're going to draw and label both by hitting trace. Neither have outliers. We would have little dots here if there were, but you can go left and right and label the 5-number summary. push down, which is list 2, Kobe Bryant. And then once we have our picture, we can compare them side by side and decide which player is better. Now, I'm going to leave the analysis up to you, but one possible answer is I would choose Michael Jordan because his Q1, his median, his Q3, and his max are all higher. But you could also argue that Kobe Bryant is a better player. Now, they're very similar. The boxes are really close to each other. The numbers are closest to each other. But you could argue that Kobe Bryant has a higher minimum, but he has a smaller range and a smaller interquartile range, so you could argue that he has better consistency. So the bottom line is you need to back up your answer with data.